Today we are going to learn another summary measure that is called measure of dispersion or variability. What is this? Variability, dispersion, or it is also called speed, measure the extent to which the values vary from central value. This is the measure of scatteredness among the data. This is also average distance between the points from the average. So let us give a simple example. In the class, we have the students. Somebody asked the student age, somebody said 19, somebody 18, somebody 20. So you got different ages of student and you can calculate the average age. Say it is 18 years. So you got the average 18 years. That is the most of the student age, or 18 years represent the student age. But see, you got some difference. Somebody said 18, somebody 17. The difference is 1. Somebody said 20, difference is 2 from 18. Somebody said 21, difference is 3 from the mean 18. Somebody says 16, the difference is 2 from the mean is 18. So you are getting the difference of ages from the mean value. How can you calculate this? How can you calculate this difference? So this difference of data we can calculate by measure of variability. So in the measure of central tendency, we calculated a single value, maybe mean, median, or mode, that represent the original data. But measure of variability represent the difference of data in terms of average, or maybe in terms of mean, mode, like that. So this is the nothing but the measure of difference. So there are many measures of variability. The important ones are range, variance, standard deviation, quartile deviation. In this course, we will emphasize on the variance and standard deviation. As standard deviation is the most widely used measure of variability, so we have to learn it. Let us see what is range. Range is very simple method to calculate the variability. Just from the maximum value, give the minus minimum value. This is the measure of variability by range. But sometimes range is very important. For the weather, you should know the maximum and minimum temperature, especially for the European country or maybe the Middle East country where temperature fluctuated. A lot of difference between the maximum and minimum difference. In the Scandinavian country, if you go to the summer, in Russia you go summer, weather will be more around 30. But if you go to the winter, the weather will be minus 10, minus 20. So a lot of difference. For this case, you should know the range. What is the maximum temperature, minimum temperature? So you can prepare. So weather forecast for maximum and minimum is very important. Range also can be used in share market, because share markets who are dealing with the share prices, they should know what is the maximum price of the some item and what is the minimum price of some item. Even if you're going to restaurant, before visit the restaurant, you should know the maximum and minimum price. So you can prepare yourself. What is the minimum value of an item or food item in a restaurant? So sometimes maximum and minimum is very important. So there are some production of cotton in kg. What is the range of the production? So this maximum minus minimum. Maximum production is 8, maximum is 11, minimum is 8. You go to 3 kg. Just the main, the range of production from 8 to 11, and the range is 3 kg. Now come to the most important one, the measure of variability, variance and standard deviation. These are two most important and widely used measures of variation. So what is variance? So variance is a measure of variability. This is the average square difference from the mean. So remember that variance is the average square difference. So you get some difference, you square it. This is the average square difference. It is denoted by sigma square, a Greek letter sigma square, or maybe S square. Sigma square normally denoted by population. When you have the whole data set, a whole item, that is the population, we normally denoted by sigma square. When you have a set of data, subset from survey you are getting. So these are the subset of data. This is variance is denoted by S square. So all our example, we have to use the S square because all our data from the sample or some other sources, not the whole the population. So we will all our example, we have to denote the variance by S square. If we know the variance, then standard deviation is very easy to understand. Standard deviation, nothing but the square root of the data, positive square root. So this is the average difference from the mean, only average difference, absolute average difference. So variance is the square difference and standard deviation is the average difference. When you will do the practical example, it will be more clear. As a variance denoted by sigma square for the case of population and S square for the case of sample, automatically standard deviation denoted by small s or capital S or Greek letter sigma for the case of population. So this is a formula. We know the data we calculate for the mean, median, mode, group data, or maybe ungrouped data. So this is the formula for the ungrouped data where data is not in tabulated from and no frequency. This is the data for the variance S square. So this is a simplified form, and standard deviation, nothing but the root over of variance. So sigma sum is, you know already, sigma is sum of the observation and x bar is the mean of the data, sample mean call. So let us see an example. These are the quiz marks of the student in any subject, 5, 4, 3 out of 10. Okay, this is the quiz mark of the student. What conclude can be made about the variability of data? So okay, it will be about the variability of. So here question about the variability. So we need to find variance and then standard deviation. Here is question not about the average or central value. So here question about the variability. So we have to find the variance and then standard deviation. Both we have to find out. The variability measured by variance and standard deviation. So let us see. As you, before you give the formula for the variance, we need the summation of x square minus n x bar square. So what is the x? X are the marks of the student. Just we make a column. This is the marks of the student denoted by x. Better you can write the small x better. Okay, and you have to square it. Okay, because you have to have sum of all the square value of x. Okay, so we have to square it and mark. We have to sum up because we need mean mark. X bar is the mean mark. Then square it. So first of all, we got the mean. We did it before. Sum of all the value divided by how many students? There are 10 students. Okay. If you count, you will get 10 students divided by 10. The total you will get 4.1. I think you will go. So you got the mean x bar 4.1. Then put the all the values in the formula for the variance 1 over n minus 1. Remember that you have to divide the this value with n minus 1, because in statistics when you want to get unbiased estimate, it is in the high level you will learn. This is the formula. Some books they use 1 by n, but that is also not wrong. There will be little difference, but better we have to use n minus 1. So put all the value, we square. This is the mean square of x and summation. So if we square the value of x and if you sum up, we'll get 245. Okay. So don't do it square it. Don't square it. Square value of x and then sum up. This means you have to first of all square the value of x, then sum up. So we put the value to 45 in 10 and we got x bar 4.1. We make the square and ultimately we got 8.54. This is the value for the variance. And what is the interpretation? I told you before, in statistics, most important part is the interpretation. Calculation can be done by computer, any program, Excel can be done automatically. But main important thing, the interpretation. They can interpret. And your knowledge, your wisdom, your experience all depend upon how you are going to interpret your result. So this is for one should write the comment or interpret after all sort of calculation, whether it is mentioned or not. So we got 8.54. There is a variance. What is the comment? As I told, variance is the average square difference. So the average square difference of what? This is a quiz mark of the student from where? From the mean mark is 8.54. Just remember the average square difference. This is the common for all the comment. Then what data of quiz mark? For whom? For the student. For which? So this is a very important. When you make the comment, just remember average square difference of quiz mark of the student from the mean mark is 8.5. So the mark varies in square 8.54. So now standard deviation, just take the root over of 8.54 because standard deviation is the root over of variance, positive root over 2.92. Same like this. So average difference of quiz mark, so interpretation for the standard deviation, just omit the square. The average difference of quiz mark of the student from the mean mark is 2.92. It will be 2.92, sorry, 2.92. So we got the variance. The average square difference of mark is 8.54. And for the standard deviation, the average difference of quiz mark of the student from the mean mark is 2.92. So this is the variance for the ungrouped data. Remember that the comment for the ungrouped data or group data is same. Just calculation is different. Interpretation is same. Just see what type of data, then write the comment. Comment is same. Okay. Let us see for the group data what is the variance and standard deviation. For the variance group data, same formula. Just we have to multiply x squared by f. Okay. This is the for group data. We have to use this second one for the calculation. All are same. One thing new, f. And what is this? X is nothing but the midpoint. When you have the class interval, you have to take the midpoint. If no class interval, just take the x. So x is the, let us see the practical example. Oh, this is the age of the student. So this is the range. Student age is given in the range. 15 to 17, 50 student, 17 to 19, 110 student, 19 to 21, 260 student, 21 to 23, 100 student, and 23 to 25, there is 80 students. So how can we find the variability of the data? These are the group data. Okay, let us see how can we do. First of all, you have to calculate the x bar. X bar we calculated before. You have to find the midpoint. From the midpoint, then you have to find the fx, f multiply x, and for the variance, we need the x squared. You have to find the x squared. Then you have to multiply this frequency, that is number of students. As I say, number of students, nothing, it is called as a frequency. So you can write here number of students. Number of students is nothing but the frequency denoted by f. So number of students. So you can put it here, number of students here, you can put, okay. So this is the number of students denoted by f, and you got the midpoint, you multiply, you will got the fx, and you have to square the midpoint, you'll get it, and then you have to multiply this f with x square, you'll get the square. This means sum of fx and sum of fx square. If we have the sum up, we'll get this value. Okay, now we knew before that what is the formula for the mean for the group data, sum of fx denoted by, here small n, capital N doesn't matter, but let us see all the way we have to use the small n. Okay, all the formula you have to use the small n. It doesn't matter, but better to keep uniformity in all the example. So putting all the value, putting all the values in the formula, as I said, for the group data only x square. So we got the summation of all the f multiply x square. So if you want to know how can you do it, so I can give you some example. So here 50 is the first one. How we got the f x square? 50 is the first one. Multiply by, let us see. Let us give some value. Let us see some value square, multiply by, it is the, what is the f square? 256. If you multiply 2 anyhow some problem maybe there, just multiply 256. If you multiply this, you will get it. I hope so. You will get it 128.00. Again, you multiply 110. If you multiply it, the frequency is 110, 110. Multiply by, if you multiply this, x square is our 324. I think you'll get this value. Okay. So this is the way to calculate the f multiply x square, then sum up, put all the value in the formula, and x square we got x bar we got 20.16. If you multiply, you will get the variance 5.1162 year square. Because variance is square, here the will be the year square. So what is the comment? Same comment. The average square difference of age of students, from the mean age is 5.12 year square. Because remember that variance is a square difference. When you have the unit, you have to give the square. Don't forget, when there is a unit in the data, you have to give the unit square. If the weight of the student is in kg, the difference will be kg square. So this is the unit. This is for, you mostly use the standard deviation. This is absolute difference. So let us calculate standard deviation. Just take the root over of the variance. You got the variance 5.11626 and you will get it 2.26. You can write it years, okay? Because indirectly you can write in years. So we got the standard deviation 2.26 years. What is the comment? Just remove the square difference. See, the average difference of age of the students from the mean age of the size of the student, whom it is better to put all the information in the comment. Whose age? It is given student age, so you have to input the age of the student. If it is given the person's age, you have to put the age of the person. Okay, so better to put all the information in the formula. Please don't forget to put all the information in the formula, because very important part of statistics in the interpretation in the comment. Your calculation will be in computer. Nobody will go to see your calculation. Everybody will see what type of interpretation we are going to write. So put all the information in the interpretation. So this is the age of the students. From the mean age is 2.26 year. So this is the comment for the variance and standard deviation. So remember, variance is the, again I am repeating, square difference, and standard deviation is the absolute difference. You can write here average, absolute difference you can put here, no problem. Absolute difference of age of the student is 2.26. So this is the way to calculate the variance and standard deviation for the group data. I put an example with the hints how to calculate it. You can do it very easy in Excel. I'll show it in Excel how to calculate. Also, you can do it statistical program R.